Okay, so we're doing 2023 IIT JEE exam, physics part 1. So in that we are at section 4. There are 4 problems. This is the second of the 4 problem, and in this you're supposed to match this with that, right? And this particular problem that we're going to do in this video is had to do with the Blackbody, and so what we are given is at different temperatures, and these are some of the effects that you must observe at different temperatures, and we're supposed to match like at this temperature, like if temperature given this, and if the consequence will be 3, so the radiation, the peak emission wavelength will be result in a widest central maximum. So if you know how to calculate the widest central maximum, this would be what you would do to decide on this. But you can see that from the choices, if you look at things that you can calculate, these are things you may be able to calculate. Maybe some of them you are more sure about. Maybe you're sure about how to do radiation is peak wavelength and what will be photoelectric effect if I use that radiation. If you're able to do that, you just go with that, so whatever you can calculate, any one of these calculate will narrow down your possibility. Okay, so if you know some of the laws, that will guide you what you can calculate quickly. Okay, so here are a couple of things you probably should know in a Blackbody. Okay, radiation. So Blackbody radiation, this is not the place to learn it, right? This is the place to kind of recall and solve things. You can study in your book or my website. Okay, so Blackbody radiation is going to be, you can say Wiens law, something called Wiens displacement law. Wiens law, it says that this is the Blackbody spectrum, and this is, if you plot versus lambda, so this is the lambda max. So where is the most of the energy is coming? Which wavelength most of the energy will be coming, right? So lambda max, things should remember it goes as 1 over temperature, and if you make it equal to, you need a constant, and that's the Wiens constant. You can actually even guess it, that it will be, law will be like this, just from the units. This unit, if you look at the meter times Kelvin, and this is Kelvin, and cancel out, and this will be meter, and that will be the unit of the wavelength. The other one, I find working on this in many problems, some is not as time saving, okay, let me put it this way, as of course if you just calculate lambda max, it is trivial, right? But usually it is combined with some other things, and those other things can take you longer time to do the problem. Then the other one is Stephan-Boltzmann law. This is actually very powerful. So this is power per unit area that's coming out from a Blackbody. It's like a sun is a Blackbody, so how much per unit area is coming out of the sun? So look at the surface area, so and divide by all the power that came out of the sun, divided by the surface area of the sun. This will go as temperature to the power 4, and this is unbelievable. A little bit of is very sensitive temperature. If temperature doubles, then 16 times the power will come out. It will come out at a different a spectrum, the wavelength maximum will be different because of that, right? But it will come out, if double the temperature, you're going to see right away, and you make it equal sigma. So this is a constant. So from here I already know T doubles, then power over area becomes 16 times, and so on and so forth. Knowing that, if I look at it, list of things I have to compute, number 4 is really, it's about Stephan-Boltzmann's law. It says, yeah, emitted by is 1/16 of that emitted variable. So if temperature becomes half, temperature halves, then P over A becomes 1/16, and that's exactly what that is. So from 6,000 it has to go down to 3,000. So Q has to be 4. So now let's look at Q5. That's not correct. Q4, that's correct. Q2. So I already C is the answer. That just says C is the answer. I really don't have to do anything more than that. Okay, C is the answer. Now if you wanted to do more than that, you can, the possibility 2 is another easy answer. The radiation at peak wavelength is visible to him and I. Now if you know that radiation, the surface temperature of the sun is around 5,000 K, and that's peak is in the visible region, so that's going to be, you don't even have to work it out to know the answer. R will have to be 2. So this one R is 2, but this is R is 2. So you would have kind of, if you just worked out that, you'll be like that. Let's just work that one out, just for the sake of, I won't be working that out in the exam situation. All have been done by this. Okay, I'll move on to another problem, but just for the sake of some of you, and I want to just do, because they're given the Wiens constant, might as well work out the Wiens constant. So let's do the Wiens constant thing. Radiation peak wavelength is visible to the human eye. So I want to figure out lambda max is 2.9 times 10 to the power minus 3, and the problem with that is we have to work out all these 4 temperatures, and if we don't have a clue, then I have to work out 4 temperatures. But if we have a clue, I'm just checking with 5,000. So this makes it this make it 3 over 5 times 10 to minus 3 meter. Okay, 3 or 6 meter. This is micrometer already in them, and this is 0.6 micrometer. So you have to know this is visible. Okay, so this is yellow red. All right, so this is, you have to know, and this actually checks out with R going to 2, and that's R going to 2, and the C was the right answer. It just checked out. Okay, I will leave that for you to do the other possibilities. There are a whole bunch of things you can do, but in the test situation you don't need to do them all. All right. Okay, so we're going to do the next problem in the next video.